we go through this, we are going to go through the waves practice problems that I emailed to you. At the bottom, you'll see that it says things and equations to know. And the one thing that I want you to add to that is that the speed of sound is equal to 340 meters per second. Because you need to know that in order to figure out number one. Once you've added that to there, we're going to start working through problem number one. So problem number one says dogs are able to hear much higher frequencies than humans are capable of detecting. If a dog whistle has a frequency of 3,000 hertz, what is the wavelength of the sound emitted? So the first thing I want you to do is look at your paper and see what is it that you're trying to find. So there are certain questions that you're probably going to want to be looking at. The first one is, what am I trying to find? The answer here is actually going to be wavelength. Okay. Now, once you figure out what it is that you're looking for, you can narrow it down to what type of an equation that you're going to use. So if you look down at the bottom, the equation for wavelength is velocity divided by frequency. So we know that our wavelength, and that's our symbol lambda for wavelength, is equal to the velocity divided by frequency, right? Now, in your problem, what are you given? You are given this piece of information right here, right? That's a frequency. You know what the frequency is. So you know right away that F is equal to 3,000 hertz. Remember what I told you at the very beginning, that the velocity of sound, or the speed of sound, is equal to 340 meters per second. If you have your velocity and you have your frequency, that's simply a plug and chug type of deal, right? So you can easily go 340 meters per second divided by 3,000 hertz, which is just waves per second, right? And when you divide the two of those out, you should get an answer of 0.11 meters. You get that? Alright. And we're going to look at the next one. The next one says, while flying to Tucson, Connie's plane experiences turbulence that causes the coffee in her cup to oscillate back and forth 4 times each second. If the waves of coffee have a wavelength of 0.1 meters, what is the speed of the wave moving through the coffee? So, you're going to start out again. What am I trying to find? If you look at this, it's right here for you, right? You have wavelength, and you are looking for what is the speed of the wave. So you are looking for wave speed. Because you're looking for wave speed, you know which equation you're supposed to use. You know that you're supposed to use the velocity is equal to the wavelength times your frequency. Wavelength times frequency. Now, what are you given about this problem? There are certain things in there that you can pull out. I gave you one of them already. So that's your wavelength. You know that your wavelength is equal to 0.1 meters, right? And then if we look over here again, from this one, it says that the coffee oscillates back and forth 4 times each second. Remember, frequency is how many waves you get per second. So if it goes back and forth 4 times each second, your frequency is 4 hertz, or 4 waves per second. So now, this is just nice and simple all over again. You take this, plug it in here, you take this one, plug it in here, and your speed, your wave speed, is equal to 0.1 times 4. And that's going to give you 0.4 meters per second. That's how fast your wave is moving. Number 3. Number 3 is just a little bit tricky in that you kind of have to look at how you can rearrange the equation, right? So 3 says, in Cali, Clay is surfing on a wave that propels him forward toward the beach with a speed of 5 meters per second. The wave crests are 20 meters apart. What's the frequency of the water wave, and then what is the period? So in here, you're looking for 2 different things. A, you're trying to figure out the frequency, right? You're looking for the frequency. The second thing you're trying to figure out is the period. What's the period of those waves? Okay. Now if we look, if we start out with letter A, or the first part of it where it says talking about the frequency, we don't have an equation for frequency that's going to help us here. So if we take our equation of lambda is equal to velocity divided by frequency, and we rearrange it a little bit. What is the opposite of dividing by frequency? You're going to multiply by frequency, right? That'll get rid of it on this side. So that's going to leave you with your frequency times lambda is equal to your speed. Now, we have to get f by itself, right? So what's the opposite of multiplying by lambda? We're going to divide by lambda. So your equation for frequency is speed divided by wavelength. If we look at this, what different things do we know? We know that our speed is equal to 5 meters per second. And it tells us that our wave crests are 20 meters apart. It tells us that our wavelength is 20 meters. You have both of these, and all you're going to do is you're going to plug them in up here. So we have the frequency of these waves is equal to 5 divided by 20. It's going to give us a frequency of 0.25 hertz, or a quarter of a wave every second. Second part of this is that we have to figure out the period. And if we look, we know that our period is equal to 1 divided by the frequency. And we know from up here that our frequency is 0.25 hertz. All we're going to do is take 1 divided by 0.25, and that's going to give us our period, which is actually equal to 4 seconds. The next one, number 4. Number 4 says, calculate the speed of waves in water that are 0.4 meters apart and have a frequency of 2 hertz. So the one thing that we're trying to look for here, the thing we're trying to find, is speed of the waves, right? So we are looking for wave speed. Now, based on what we're given, we know that the length of our waves, or lambda, is equal to 0.4 meters. We also know that our frequency here is 2 hertz, or 2 waves every second. If we are looking for wave speed, we have an equation for that. It's already given to us. We know that our wave speed is equal to lambda times frequency. This is a very, very simple plug and chug type of thing. So we know that the speed of that wave is equal to 0.4 times 2. Which, if you do the calculations, ends up being 0.8 meters per second. That one was kind of a fun one. Just a nice little easy problem. Number 5. Melanie is new to the nursing program. With a patient, she counts 84 heartbeats in 1 minute. She calculates that the period and the frequency of the heartbeats are 0.71 seconds and 1.4 hertz respectively. Is she correct? So, with this, she says that the period is equal to 0.71 seconds, and her frequency is equal to 1.4 hertz. Is she correct? In order to figure this out, you're going to want to kind of take a look at the math behind this. You have to try and figure it out yourself first. So, if it says that we are looking at 84 heartbeats in 1 minute, we know that we have to break that down to how many heartbeats per second. Okay? So, how many heartbeats per second? That's going to give us our frequency, right? So if we look at this, we have 84 heartbeats in 1 minute. And we know that 1 minute is equal to 60 seconds. So we are going to go and we're going to take 84 divided by 60 because we want to know how many per second. And if we divide 84 by 60, we end up actually getting 1.4 hertz. So far, she looks like she's doing it right. She's found her frequency is 1.4 hertz. Now, if we're trying to find the period of that, we know that all we have to do is take 1 divided by the frequency, or just 1 divided by 1.4, which is what we found up there. We found if we actually do that math and go through and calculate it out, it actually ends up being 0.71 seconds. So the part of the question, is she correct? And you would have to explain. You could easily say that she went through and she broke it down with her frequency being per second, not per minute. Because that's where most kind of mistakes happen, is that they don't break this minute down into the seconds part. And then from there, it's a simple figure it out down here to figure out what your period is. Okay. Number 6, for this one. If a wave vibrates back and forth 3 times each second, and its wavelength is 2 meters, what is its frequency? What is its period? What is its speed? So we have 3 different things that we're trying to find here. So we are looking for frequency, for period, and we are looking for wave speed. When we talk about frequency, we know that frequency is the number of waves per second, right? Or the number of waves per given unit of time. If we look at what the problem tells us, it tells us that a wave vibrates back and forth 3 times each second. So if we're talking about back and forth 3 times per second, that is our frequency. So our frequency ends up being 3 hertz. So once we figured out our frequency, we can go on and figure out what the period is. So when we look at period, we know that it is 1 divided by our frequency. Same equation that we've always been using. And that ends up being 1 over 3. You can leave it like that, or you can say 0. Oops. Or you can say 0.33 seconds. Either way is fine. The last part of this is our wave speed. So we have our equation for wave speed. We know that wave speed is equal to lambda times frequency, right? And it tells us in our equation that lambda is equal to 2 meters, and we figured out that our frequency is 3 hertz. A simple multiplication problem at this point. So your wave speed is equal to 2 times 3, which is equal to 6 meters per second. This, in and of itself, is going to be the extent of what you're going to have to be able to do for your test. This is the type of conversion back and forth that I'm going to expect you to be able to do. Being able to calculate wave speed and period and frequency and know when to use which equations. You'll be given all the equations that you were given today, plus the one I had you get about speed of sound. And that's about the extent of it.